Hi friends, welcome back to More Math with Ms. Beck. Today we're going to be talking about the measures of angles in triangles and how to solve for missing angles. Pause the video to get some work paper and a writing utensil. Our focus for today are two things. The first thing we're going to be doing is analyzing the triangle. We're looking for clues in, on, around the triangle to help us to solve. Our second concept is we're going to be doing some close reading. We're tuning into math words in order to help us to solve successfully. But let's have a quick review first. We know now that we have learned that all triangles measure 180 degrees. And what this means is that the three angles in the triangle have a sum of 180 degrees. Let's look at a few of the equations that we've been using for solving for missing angles. Here's an equation for solving for missing angles in a scalene triangle. Now this triangle happens to be named PQR. The triangle can be named whatever the author decides to name it. So in this problem, it is P plus Q plus R equals 180 degrees. An equation for solving for missing base angles in an isosceles triangle looks like this. We know that our base angles are identical. They are giving us the other angle. We subtract that known angle from 180 degrees and we divide the difference by 2 since our two base angles are identical. Another equation for solving for missing angle in an isosceles triangle is when you're given a base angle or even two base angles and have to solve for the third angle. We multiply the base angle by 2 and we add it together with the unknown angle, or we multiply the base angle by 2 and subtract the sum from 180 in order to find the angle at A. We've also learned some pertinent information about the equilateral triangle. The equilateral triangle is named for its equal side lengths. However, we also learned that all three of its angles are equal as well. All angles in an equilateral triangle always measure 60 degrees. Moving on, let's analyze the triangle. Look closely at triangles LMN and RST and analyze them, meaning what do you see? What are some things that can help you to solve for the missing angles? If you were looking closely and carefully, you would have noticed that each triangle shows a right or 90-degree angle. There's a right or 90-degree angle here at the corner or vertex labeled L. There's also one here in this triangle at the vertex or corner or angle labeled S. Taking time to analyze the figure often provides us with clues that help you to move forward towards solving the problem. Now we know values for two angles in these triangles, and you know how to easily solve for the third. Let's look at the one that was on the right. So we show the 45-degree angle, and we see the right angle on the right at S. Now we know one angle measures 90 degrees and another measures 45 degrees, and we can use that formula to solve for the angle at T. R plus S plus T equals 180 degrees. Now we substitute values for variables to solve. We have 45 plus 90 plus T equals 180 degrees. Now we simplify that equation by adding the 45 and 90 together. And we have 135 plus T equals 180, leaving us a part and the whole. And we know when we're solving for the other part, we simply subtract what we know. We know 180 degrees minus those two parts together, 135 equals 45 degrees. So we have another 45-degree angle at T. So the measure of angle T equals 45 degrees. Here's something you may or may not have seen before. It's one big triangle, ABC, that has been bisected by line CD to make two smaller triangles within it. We have triangle ACD inside that big triangle. We also have triangle BCD within that bigger triangle? Take a look. Before we get started, what important piece of information can you recall that's common to all triangles? Pause the video and think about it. That's right. All triangles have a measurement of 180 degrees. That's funny because there's three triangles here. The big one labeled ABC, which has a measurement of 180 degrees, but so do the smaller ones within it. ACD has a sum of the three angles that equal 180 degrees, as well as BCD. The sum of those three angles also equal 180 degrees. Let's try to find the measure of angle ABC. ABC is this angle here. Don't forget, when we're naming an angle, this is an angle, not a triangle. ABC. That center letter B is the vertex or the angle that we're trying to name. Same with BCD. It's the angle at C that we're trying to find the measurement of. BCD, this other angle that's marked right here. If you'd like to try to solve this on your own or attempt to, pause the video, copy the triangle, and fill in what you know first. There is a 90-degree angle marked at angle BDC and another next door at ADC. Well, that's funny because I don't see that angle at ADC. I see the one at BDC marked right here, but I don't see the one marked right here at ADC. Well, let's recall some prior knowledge. This line right here, AB, is a straight line. And do you remember what the measurement of a straight line is? Pause and think. That's right. A straight line measures 180 degrees. Therefore, if part of it is 90 and you subtract that part from the 180, the other part is 90 as well, which gives you a 90-degree angle here and one right on the other side of it right there. Now look what you have. You've filled in lots of pertinent information to help you move forward. You now have two angles in triangle ACD. ACD. You have that 74-degree angle there and the 90-degree angle there. You simply need to use the formula to solve for the third. Add the two you know together to get a sum of 164. Then subtract that combined part from 180, and you get that angle right here, the little one at C, which is 16 degrees. Voila, look at you. Let's move on. Since there is a 90-degree angle at angle ACB over here, and we know part of it is 16, we simply subtract that 16 from 90 to get that angle at DCB, the one that is marked right here. So using the formula 90 minus 16, we get 74 degrees, which is the measure of this angle right here in the corner. Now look, we have two angles for this triangle BCD. So we're going to use our formula to get the third angle. 90 plus 74, these two combined angles, equals 164. We subtract that sum from 180 and we get 16 degrees for this angle as well. And look what you have done. Carefully and slowly, you have found all of the angles in both of these triangles to solve for all the missing angles that you were asked to solve for. Let's try another. We're going to try to find the measure of the angle CBD. CBD. So it's this angle marked right here. Well, let's pause the video and think about what you see, and if you'd like to, copy what you have in front of you down on a piece of paper and try to work it out. Look closely at all of the triangles. What do you see that you have learned? Well, we have triangle ABC, We also have triangle ABD and triangle DCB. This time, we're going to look at it a little differently. I see an angle marked 42 here in the corner. I also know that this angle in the biggest triangle ABC is a 90-degree triangle. So if I know this is 42 and this whole thing measures 90, I can find this angle here at C. I'm going to let you complete this knowing what you know about an isosceles triangle. You can do this, friends. Now it's your turn. I want you to pause the video and find the measures of angles ABC, ABC, which is this angle marked here, and CDB, CDB, this angle marked here. Make sure you copy the triangle down exactly and fill in what you know. That was easy, or at least it wasn't that bad. You can do this. Let's move on to some triangles whereby we need to do some close reading. One of the base angles of an isosceles triangle has a measurement of 32 degrees. What is a measurement of the angle that is not a base angle? What information do the words offer you? Pause and think about it before you move on. Well, we know it's an isosceles triangle, and this is marked to show you what you know about an isosceles triangle. Here are the base angles, which are congruent. If one is 32 degrees and they're congruent, so is the other. Now you know two of the three angles, and you can use your formula to solve for the third. 32 times 2 is 64. So those two base angles combined is 64 degrees. Then you subtract that big part from 180 and you get 116. So the measure of the unknown angle at the top is 116 degrees. I want you to take note that this does definitely not look like a 116-degree angle, but we are simply going on the words, and you will find several problems like this in your education. Use the words to solve the problem. Now it's your turn. An angle in a right triangle has a measure of 42 degrees. What do the other angles measure? Pause the video and think about this. Try to solve using the words that are right in front of you that we read. You did a fabulous job today. Remember, you always want to analyze a problem first. Read carefully. You got this, friends. Work carefully and slowly, and you will do great.